Alright class, today we're going to dive into the fascinating world of waves and how energy is transferred through them. Waves are all around us, from the sound waves we hear to the light waves we see. But how exactly does energy travel through waves? Let's find out. First, let's talk about the two main types of waves, transverse waves and longitudinal waves. Transverse waves are waves in which the particles of the medium move perpendicular to the direction of the wave. Imagine a wave moving across a string. As the wave travels, the particles of the string move up and down, creating a wave pattern. This is how energy is transferred through transverse waves. On the other hand, longitudinal waves are waves in which the particles of the medium move parallel to the direction of the wave. Think of a slinky being compressed and expanded. As the wave travels through the slinky, the particles move back and forth in the same direction as the wave. This is how energy is transferred through longitudinal waves. Now, let's talk about how energy is transferred through these waves. In both transverse and longitudinal waves, energy is carried by the movement of the particles in the medium. When a wave is created, it transfers energy from one point to another, without actually moving the medium itself. This is known as the transfer of energy through waves. One key concept to understand is that waves transfer energy, not matter. This means that as a wave travels through a medium, it carries energy with it but does not physically transport any particles of the medium. This is why waves can travel through empty space, like light waves traveling through the vacuum of space. Another important concept to grasp is the idea of amplitude and frequency in waves. Amplitude refers to the maximum displacement of a particle from its rest position in a wave. The greater the amplitude, the more energy the wave carries. Frequency, on the other hand, is the number of complete waves that pass a point in a certain amount of time. The higher the frequency, the more energy the wave carries. Cross-cutting concepts come into play when we consider the relationship between energy and waves. Energy is a fundamental concept in science, and waves are a key way that energy is transferred through the universe. By understanding how waves transfer energy, we can better comprehend the interconnectedness of different scientific phenomena. So, to recap, energy is transferred through waves by the movement of particles in the medium. Transverse waves involve particles moving perpendicular to the direction of the wave, while longitudinal waves involve particles moving parallel to the direction of the wave. Waves carry energy through the transfer of energy from one point to another without physically transporting matter. By understanding these concepts, we can gain a deeper appreciation for the role that waves play in our world, and how energy is transferred through them. Waves are all around us, shaping the way we experience sound, light, and even seismic activity. So the next time you hear a sound or see a light, remember that energy is being transferred through waves right before your eyes. Now, let's take a moment to think about some real-world examples of how energy is transferred through waves. For instance, when you hear a car horn honking, sound waves are traveling through the air and reaching your ears, transferring energy from the car to you. Similarly, when you see a rainbow in the sky, light waves are being reflected and refracted through water droplets, carrying energy from the sun to your eyes. In the field of medicine, ultrasound waves are used to create images of internal organs in the body. These waves travel through the body and bounce off different tissues, transferring energy that is then converted into an image that can be seen on a screen. This technology allows doctors to diagnose and treat various medical conditions. In the field of engineering, seismic waves are used to study the Earth's interior and detect underground structures such as oil reserves. These waves travel through the Earth's crust and bounce off different layers, transferring energy that can be detected and analyzed to provide valuable information about the Earth's composition. Overall, waves play a crucial role in transferring energy through various mediums and are essential for our understanding of the world around us. By studying how energy is transferred through waves, we can gain insights into a wide range of scientific phenomena and develop new technologies that benefit society. So next time you encounter a wave, whether it's a sound wave, light wave, or any other type of wave, take a moment to appreciate the intricate process of energy transfer that is happening right before your eyes.